A 7 kg box is attached to a 3 kg box by rope 1. The 7 kg box is pulled by rope 2 with a force of 25 newtons. Determine the acceleration of the boxes and the tension in rope 1. The coefficient of friction between the ground and the boxes is 0.120. Here, two boxes of masses 3 kg and 7 kg are attached by a rope 1, and both the blocks are pulled by rope 2 with a force of 25 newtons. Now we have to find out the acceleration of the blocks and the tension in the connecting rope. Here is the free body diagram. This is the force of pull and this is the tension. And then normal force and gravity are acting vertically upwards and downwards. And then friction in the negative x direction. Okay, this is the for both the objects individual free body diagram, this one. Now what is happening here? The second rope is pulled by a force of 25 newtons. So the entire system is accelerating. Am I right? So for that, I have written another free body diagram. So taking both the boxes as the single box as of 10 kilograms. So 10 kilograms box is here as if it is the 110 kilogram box. And then gravity acts downwards and the normal force upwards. And then this is the force of pull and the friction in the opposite direction. As the box is moving towards right, the friction is towards left. Therefore, net force is equal to MA, Newton's second law. So the net force is F pull minus F friction is equal to MA. Now mass is the total mass, 10 kilogram mass. I am doing the analysis for the entire system as the single system, two masses as the single mass of 10 kilograms and doing the analysis. Therefore, the acceleration, because the second rope is pulling both the masses, therefore I have to find out the acceleration of both the masses. Therefore, the acceleration is equal to 1.32 meters per second square. Now, next comes the tension in the rope 1. For that, here, sigma F is equal to F tension. Again, the net force is equal to MA. So the net force is tension minus friction is equal to MA. Here you are seeing, for the 3 kg block. Now the 7 kg block is out of system and 3 kg block because we have to find out the tension in the connecting rope. So Ft minus F friction is equal to MA or Ft is equal to F friction plus MA. Now MA is 3 times acceleration, the mass of the 3 kg block. No, so 3 kg times acceleration. Acceleration we already found out. And then friction. To find out the friction, again here, Fn minus Fg by sigma Fi is equal to Fn minus Fg is equal to 0. Same way, we have to find out. Fn minus Fg is equal to 0. Ay is equal to 0. Therefore, Fn is equal to Fg. So here Fg is equal to 3 times 9.8. And then F friction is equal to mu Fn. Therefore, mu is 0.12. Therefore, 0.12 times 3 times 9.8 gives 3.528 Newtons. So this is the friction between the 3 kg block and the surface. Now, adding that friction to the MA, we get the tension as 7.5 Newtons. Okay. Here we have to do the problem in 2 bits. One is taking the two masses as the single mass and then analyzing the forces and then finding out the acceleration. Once we find the acceleration, then we have go for the individual analysis, individual masses analysis, and then find out the tension. We have to find out again the friction and then apply that friction, and then we have to find out the tension in the string. Okay. Hope this helps. Thank you. Bye bye.